Welcome, y'all. Today we're talking about the real number system. All right, so let's kind of go over the subsets, the how this system come to be. So we have what we call our natural numbers. These are the numbers we're usually just talking about: one, twos, threes, fours, anything from zero. Natural numbers are any positive numbers, so starting at one up, and then we include the zero. So this is our main set of numbers. Then we have what we call the whole numbers. That includes the zero in there, so we call those whole numbers. Then we look at our negative numbers, so -1, -2, -3. If we continue with that, when we put the whole numbers and negative numbers together, those are called integers. So as we talk about integers, we know that we're talking about anything from any positive or negative number, but they're still, solid, just normal numbers, integers. Then we add fractions. Fractions are 1/2, 3/8, 5/13, so on and so forth. Those two together make what we call the rational number. So any number that can be divided. And then you talk about the irrationals, numbers that don't repeat, that when you square root them, give irrational numbers, don't square root nicely. So rational and irrational together make what we call our real number system. These are all possible real number systems. If you before in algebra 1 or probably algebra 2, you also talk about imaginary. That's the other subset over here next to that. Imaginary, which is our eyes. So that's what they're in the same level. Real numbers and imaginary. All right, so that's just some ideas. So rational numbers, again, the examples are like zeros, negative numbers, fractions. Even decimal numbers, they repeat. Those are real numbers still, or rational numbers. Irrational are just like that. Numbers that one continue on forever, do not repeat, and don't have a necessarily pattern. Even though there is a pattern here for us, you see a 1, 2, then a 1, 2, 2, then 1, 2, 2, 2, so on and so forth. It doesn't have a mathematical pattern. It just happens to kind of happen that way. So they're still considered irrational numbers. But the main thing we were talking about today are our interval notations. How do you write something on a graph to see it? Sometimes when we look at it as a picture form, we're able to kind of look at it a little better. These are graphical representations of inequalities or equalities. So for example, this is saying that what is the value of some number, x in this case, that is greater than some value a. So to graph that, you say, all right, you start at a, say I want all numbers greater than a, bigger than a. So that's why we put a parentheses, and that's the main part we'll talk about today. What type of symbols? So if it's a less than or greater than sign, we will always use parentheses, either one of them or both of them. If we're talking about less than or equal to or greater than or equal to, we use brackets. Brackets mean that it starts at this point or ends at this particular point and goes on either greater or less than or in between. Now we have open intervals. Open interval means it starts at one place and then goes on forever. Starts at one place, goes on forever, starts at one place and goes to it. Now the reason this is also considered open interval is because it never goes strictly to a single endpoint. So we're saying, for example, a less than x less than b, we'll make up a number. Let's say 1 less than x less than 3. So we're talking about all possible value between 1 and 3. Now, our interval will look like this: 1 to 3, parentheses, the line in between. Here's the thing: the value of what possible numbers can exist in between these two numbers is infinite, because I'm getting close to 3, but not ever touching 3. So that means I'm 2.9, okay? But I could also be 2.99, which is even closer, or 2.999, which is even closer, 2.9, and so on and so forth. That's what they consider it open notation, because there's never an absolute value. Like, all right, it starts exactly this and ends exactly here. It starts at 1 but not 1, and it ends at 3 but not 3. Sounds a little confusing, but understand, this will always get as close as possible to 3 without ever touching it. All right, now half open intervals are intervals where it starts at an absolute point and then goes on either forever or goes to a almost close to numbers. So for example, we have our x is less than or equal to a. That means, for example, if x is greater than or equal to a, let's say a is, good a number, 4. We're saying that the value of x is any number 4 or greater. So on a line graph, we have 4 right here, and so we put our bracket on there right at the 4, and then we draw our line saying, hey, the value of x is any number starting at 4 and it goes over. So we have a starting point. It is at the very smallest 4, but then it can be any number bigger than that. That's where we draw our arrow to the bigger side of the numbers. Again, in math, to the left means small, to the right means big. So bigger numbers go to the right, smaller numbers go to the left. So they're half intervals. There's also this one right here. This is considered a half interval, half open. So it's a less than or equal to x less than b. So we can use the number 1 and 4 like before. We say 1 is less than or equal to x, which is less than or equal to 4. So when we're drawing this particular problem right here, we'll have our line. We got our 1 right here, our 4 right here, and it's x can be 1 is less than or equal to x. That means we put our bracket right there because it could be 1, but it has to be bigger than 1. But x is less than or equal to 4, so it's any value smaller than that. So we put a parentheses on there. It means it can be any number in between here. It can be 1 for sure, or any number close heading towards 4 but not 4. It means it can be 3.9, 3.99, 3.9999. That's why it's half open, because this number over here will never know the absolute smallest value, closest biggest value, because you can always just add another 9 and another 9 and another 9 and another 9. Now the absolute closed intervals right here are ones that have the same symbol, a less than or equal to x less than or equal to b. These two less than signs right here. That means it starts at one spot and ends in another spot. It can be any number between, but has an absolute small and an absolute great. So let's kind of practice this. So we're going to write the interval notations for this problems. So this is how you see them written sometimes. The way you say this in math is x such that, this is a fancy symbol for such that, excuse me, such that -4 is less than x, but x is less than 5. So, and it's again, x is in between these two numbers, so more than likely that's where our line graph will look like. Have our line graph. Get a little bit straighter. We have a -4 over here, and then a 5 over here. Now it tells us that the value of x, -4 is smaller than x, but x is smaller than 5. That means x is greater than -4, but x is smaller than that. So because of the type of symbol this is right here and right here, it tells us they're going to be brackets. X, the value of x is in between these two, here and here. And that's our answer right there. That's how this notation will look like graphically. All right, x such that x is greater than 1.7. So this is just saying that x can be any number greater or equal to 1.7. So even though it's written where the x is on the left, it doesn't mean that's how it is. Let's find 1.7. I said this right here is 1.7. Can x equal 1.7? Yeah, that's this little bar right here. It says x can equal that. So we can put our, but it also says that x is greater than that. So it can be anything bigger than this. But it can also equal 1.7. So that's why you put a bracket right there, the 1.7 mark. All right, so we got the next one. X such that -5 is less than x, and x is less than or equal to -2. So this should already tell you this is going to be a parentheses, and this will be a bracket for this symbol over here. And it'll be in between these two, greater than -5, smaller than -2. So let's say this right here is our -5. This right here is our -2. X is greater than that, so parentheses, but less than or equal to -2 bracket. So this is one of those half open ones where there's a for sure bracket on one side, an absolute n, but then a about end right there. And this last one says x is less than radical 5. X is less than radical 5. Again, you're making up your own number graph. Just kind of draw your arrows. Now these arrows means it goes forever that way and forever this way. Here it says -5. So we'll say, oh, radical 5. So that should be, this is a 0, roughly about 2 point something. Yeah. So we'll say this is radical 5. It doesn't have to be the most exact because this is a half open because x is less than -5. So x is going to go to the smaller side. Smaller than side will be towards our left. And because it's just a less than sign, that is a parentheses because it's not or equal to, it's a parentheses right on it. There you go, right on it. All right. So let's talk about a couple other things. Now these are properties of real numbers. You don't necessarily have to copy this down. This is just certain rules. If you know your PIMDOS, then you know this how these things work. Cumulative property means if you add them one way, they would be the same way. Cumulative property of multiplication, same thing. 2 times 3 is the same thing as 3 times 2. Associative property means what you associate first, or what you put in parentheses first, you have to do that work the same. But when it comes to addition, it doesn't matter what comes first. They're all going to add together. Same thing with multiplication. They're all going to multiply together. It's when you mix them up where they become addition sometimes. Distributive property means that if it's 3 plus 4 times 2, remember you do your parentheses first, you'll get 7 times 2, but no different than if you were to multiply this with this first, this with this, and then add them. The identity property means what do I add to a number to get that exact same number. In addition, in subtraction, it's 0. 3 plus 0 is 3, 3 minus 0 is 3. In multiplication, it's always 1. 3 times 1 equals 3. 3 divided by 1 is still 3. Our inverse is what will get it, what's the opposite, what will get it to 0. So in addition inverses, we're looking at, it always be the negative version of that same number. But in multiplication, it's always the reciprocal. The reciprocal, we call this the reciprocal. So if this was 3 over 2, our original number, we multiply that by the reciprocal, which is 2 over 3. That gives me a 1. So reciprocals will always do that right there. All right. And let's talk about absolute value. Now, absolute means exactly that. Absolute. What is the actual value? Think about this as in distance when you're driving somewhere. It doesn't matter if you're driving 20 miles to the west or 20 miles to the east. You're traveling 20 miles, period. So whether you're going negatively or positively, you're still going that far away. So, for example, here we look at find the distance between -2 and 3. And we were trying to just add those together, we get 1, but that's not the absolute value distance. Let's look at this in a number graph. So let's say this is -2. So then it's -1, 0, 1, 2, 3. So I want to know what's the distance from here to here. And from looking at it, that's not 1. So let's count the spaces. From starting at -2, -1, that's 1, to 0, then the 1, to 1, to 2, to 3. So that's 1, 2, 3, 4, 5. 5. So the distance between a -2 and a 3 is 5. What is the absolute value of negative radical 25 with the bars like this? Now, these little bars like that, whether you see them like -3 like this or like this, means this is a symbol for absolute value. What is the actual value of this? So whether the inside has the negative, it doesn't matter. When you do the absolute value of whatever's in here, the answer will always be a positive value. In this case, 3. If it's already positive, you put an absolute value mark on it, that's still positive. But let's look at this problem. We're saying, hey, what's the absolute value of negative absolute value radical 25? So the sign on the outside does not affect the inside at all. Not right now. So we got radical 25. So to simplify this, what's the square root of 25? 5. That's simplified. Now, what's the absolute value of 5? It is 5. We drop our absolute value bars and then bring in that sign. So the final answer here is negative 5. So understand this negative absolute value of radical 25 is different answer than this right here. That's a completely different answer right there. Let's look at that. So inside out, we take care of this. What's the absolute value of 25? It is 5. And then what's the absolute value of negative 5? It is 5. Again, anytime you do the absolute value of any number that's in between those two bars, it becomes a positive answer ultimately. This did become a positive answer, but this negative sign, because it's on the outside, came down with it as well. So these two are that different. That's the difference between these two. It's the difference between saying positive 5, so I owe you $5, or you owe me $5. Being negative 5 or being positive 5. All right, that's the lesson for today. Y'all have a great day. Bye.